Hey everybody, welcome back. CLG Performance. Um, Today I got a 2003 Ford Mustang. It is a 3.8 liter and it's having oxygen sensor issues. So I'm actually going to go through and test to see what's going on and maybe troubleshoot. The one ECU that's on the left, that is a ECU that the customer gave me that's exactly the same match. That I'm going to do a compare test on it to verify that it's actually a problem with the O2 sensor and not something else that's going on with the system. So we're actually going to test out and see if um, possibly something was overlooked or whatnot. But looking at the wire diagrams, I did notice going through that all the positives on the heater circuits, because this is the code that he was getting was, what was it, 1451, I believe it was. I don't know. I have to look back on my notes and stuff. And TV printer right here going in the background, but he said he had a problem with the heated oxygen sensor, bank 2 sensor 2. The heater was not turning off. So after doing some, pre-testing on this in between pins 96 and 95, I noticed that they are shorted together on both ECUs. So on both of these ECUs, they exactly match. So I'm going to show you this real quick. This is the chip, and a couple of these drivers right here is what controls oxygen sensor kicking on, and we're gonna go through. I'm gonna show you this wire diagram right here. You can see pins. These sets of pins are actually together inside the ECU. If you test it out, so 93 and 94 go together, and 95 and 96 are grounded together internally in the ECU. So he has a code for the heated oxygen sensor 2 not turning off. So we're actually going to test, and we're going to hook up to this pin. We'll just hook up to 96 first, and we're going to start testing. This is the original ECU. So 104, 3, 2, 1, 100, 99, 98, 97, 96. Is that correct? 96, okay. And then 95 is also paired to it with me. I can show you that it's paired to it. We'll do a continuity test. So make sure that it works first. Microscope out of the way a little bit. So this is pins 95 and 96 together. They are grounded to 0. And the same thing goes for 93 to 94, grounded. And I can also show you on the other ECU the same exact thing. This is a good ECU that he had no problems with. So this is, was it 93, 94, and 95 and 96. All of them are grounded internally, but they're not grounded to one another. So it's just the bank 1s are together and the bank 2s are together. So when he has a code for a heated oxygen sensor, bank 2, sensor 2, it's telling me that something's not right. The oxygen sensor may not be coming up the temperature quick enough. But if one heated oxygen sensor is on, both of them are on because they all share the same positive power circuit on the wire diagrams. Each one of them are interconnected to one another. So that's the bank 2 sensor 2, and it also pairs into the bank 1 sensor 2 and the bank 2 sensor 1. Now on the bank 1 sensor 1, it actually goes up to the positive feed, but it comes back out and then loops back through and shares that same positive feed further back into the harness. So, and also powers up a bunch of different other things on there. So all the power share. So since the heated oxygen sensor on Bank 2 sensor 2 share, let's see, this actually goes up to pin 96. If I go to 95 and follow it, it goes to Bank 1 sensor 2. So it's both downstream sensors on both sides of the motor. Both of them share powers. Both of them share grounds through the grounds to the ECU. So we're gonna do some preliminary tests. Everything that I tested on this thing, I already hooked up the curb tracer to it. I don't want to really show that because it's very tedious when you have to go through and check all this. At first, I thought it was internally shorted, so I went through and did a pin test and checked the grounds just by, picking up the 10. So right here, these actually hook up to pins 95 and 96. And these two over here are 93, or let's see, 93 and 94. And they're together. So these switching transistors right here are all for the oxygen sensors, the ground switching side of it. Everything that I checked with these have tested okay. They're not shorted to ground right here because this is actually ground. I can actually show you that it is ground. As anything that you find that's a ground plane, there's a ground, there's a ground, there's a ground, and there's a ground. I'm not getting anything on the other pins whatsoever. All of them are matching up. All the ohmages are matching up. Even on the outputs, not seeing anything there. So let's flip it. Let's put the positive lead on the ground, and then we're going to check it again. So there's my ground. That's my gate. It says 7. It's a 706. So it's 706 ohms. See what the next one is. 705 ohms. 706 ohms. 712 ohms. So we'll verify that. So let me go a little further here. Test this out. I'm sorry, that was voltage, not ohms. I was reading the wrong thing there. So it's 0.7 forward voltage on it. So let's check it for switch it around. Let's see if I get a reading off of this. Some ohmage. Get anything? All right, let's go up a little higher. Let's go into the 2 mega ohm range. Bring this ground back up. Check. 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 Not seeing anything. It looks like it's shorted or anything. So I'm wondering what's going on here. Okay, let's reverse it. Let's put positive on the ground, or the positive lead on the ground, and check what the ohmage is. Okay, it comes up and it faded out. It's fine. It's fine. So these are all okay. I'm not really seeing any shortage issues, saying that the oxygen sensor is still on. So I'm wondering what other kind of other issues that he's having here. So these gates are actually controlled by. Let's see where they're at. Let me double check. Let me put it on annuity test here, and then check see what's going on. Okay, so, and this one. Okay, so the pre-driver is this chip right here that commands these chips on. There's nothing wrong with this, so let's get things wired up. I want to power this ECU up, and I want to see if these gates are actually being held open with this chip right here. The chip is it's a Motorola chip. The part number is, it looks like 103 4SE001. You probably can't even see that on the camera there if I get a little close. No, I don't think you can kind of see it there. Let me zoom in that far. Maybe not. Let's go down a little further. It's this chip right here. Yep, not really seeing anything there. So let's skip this test. Let's go ahead and get the powers on the ECU. Everything that I tested as far electrically, even with the curve tracer, I'm not seeing anything different in these chips, and definitely not seeing any kind of shortages compared to the other one either. But I want to make sure that I'm going to do a full good test on this thing, and we're going to power up this ECU. I got the wire diagrams here, so I'm actually going to get everything hooked up and verify. And then I will be right back. I'm going to pause the video here, get everything hooked back up, and then we're going to run the test that way, and you'll see it on the thermal camera, and we'll go from there. So let's pause the video here. All right, everybody, I'm back. I went ahead and switched over to my other workbench area just to kind of show you that the O2 sensors are kicking off and the ground switching is working on it like it's supposed to. So something else is going on with the vehicle. So let me get this camera a little bit in focus. There we go. So this is my downstream sensor resistance. This is my upstream. And on the positive side of it, I have a light bulb that kicks on whenever the O2 sensors are warming up. So that's going to stay on until the warm up. But let me turn it off. Actually, let me turn these lights off right here. All right, so first turn on, it turns right off. You wait a few seconds. So it turns off right away. This is bank one, or the upstreams, and this is the downstream sensors. So lights off right now. The ECU is running. As you can see, the lights over here flickering on it. Let me get it on the scope so you can actually see it there. Look at the data packets that's coming through if you want. But let's get it. There we go. This is this. And 10 has the data on ground. It's going to show you this thing. This is hipwire data here. I'm not sure if that is 100% my data. This. Yeah. Signal again. There we go. Yeah, that's my data line there. So you can actually see that I'm getting data. Figure. Use the size there. There we go. So that's just all the data packets that's coming through. And I got my scan tool hooked up to it. Let's get this going here. Let's set this. See this out of the way a little bit. Maybe I could set this in here without it interfering with anything. Get the mag going. Let's see if it'll auto read. It probably won't since it's a 2003. But we'll see. All right, it's reading some of the data protocols. It's thinking that it has CAN, but it don't. So read my motor scope, that's the CAN signal, but there's no CAN. So see if it auto detects. If not, we'll have to manually put in 03 model. Just wanted to see. I got the data link connector hooked up as it is on the pins. Oh, look at that. It is on. Switch it on. Leave that on. Let's turn it off for a second. So we don't have a veil, so let's go to Ford. Read. You know that it will. Since it is an 03. Then switch manual selection now. So Ford. Mustang. And it is a 3.8 liter. And it is a 2003. So hit OK. And it doesn't matter. I'll just say no on the traction control. Because none of the extra stuff is actually on it right now. Let's put this in focus here. Let's see. Little area is warming up pretty good. What is that temperature? About 100. That's normal. All right, transmission. I did not get the information if it was automatic or not, but I'm assuming it isn't automatic because most 3.8s are. It is a gasoline. And let's see if it scans the powertrain control module and finds it. It says no response. Okay, so maybe there is more than 3 DLC connectors. And see if we can actually find. Okay, DLC 10 and 2, that's what I got. Let's make sure everything's correct. 13 is 13, that's correct. 15, 14. This side we did not see. So 14 and 15. And okay, didn't like this plug, so maybe that was my issue here. Let's see if it's back up. So make sure it goes good here. And then 16 goes to 2. So 10 goes to 15. And they go one time. And 13 goes to 13. I'm just gonna double check that now. So 13 is on 13. All right, OBD 10 is connected to 15. So I'll double check. 14, 15, so 15, okay. And 16 is 2. See that? Let's see if we read it again. Okay, now it reads faulty, so one of my pins wasn't connected good. All right. So it says fuel rail pressure, and then which is a 0193, and a P1000, of course, because battery disconnection. So let's go ahead and get into this ECU. Check things out here. Maybe if I turn the light on, you can see the screen. Maybe. And active tests. Okay. So this is the ECU 3.8. I had to pause the video there for a minute. Now I'm back on it. We got communications to it. So now this is my upstream O2 sensor, downstream O2 sensor, resistor heater. That's supposed to be my heater circuit. And I have a light on the end of it that'll indicate if it's getting the ground. Right now it's not showing anything, and you can see that my computer is live. Oh, it turned on just now. So maybe we have got a bad connection right here. We'll find out. So let's check my connections. Let's just keep this on here. All right, let's turn it off. And if it's intermittent, okay, see it. All right, let's do it one more time. Turn everything off. On, comes off for a second, and then there you go. So let's get to testing with the OBD2 scanner. Let's make sure that I got communications first. See the UC information. Okay. You said that the live data would show either circuit being on or off. Let's see if that's true. With an intermittent signal, yep, if I do an intermittent signal, it actually kicks on. Let me fix this light. Let me see what's going on here. Give me 1 second. I think that thing is so intermittent that it's making it come back on. So let me pause the video. I'm going to fix this light real quick, and see it's staying on right now because I think disconnecting and reconnecting it makes it do it. So let me pause and then fix this and then get back to it. Okay, I'm back. So I got the wiring fixed on the light bulb. So let's just go put this up. Turn it back on. Make sure to get the camera on everything so you can see. There we go. Turn it on. Light comes on for a second. Now get back to communications. Heated exhaust bank. Off, off, off. It shows off on all mine. So let's see if I interrupt one of these, if it will do something. Interrupt that and then plug it back in. Okay, so if it's interrupted, which one does that one? That's the upstream. It stays interrupted. So, and it just says off on all these, but it's actually on. So if you get an interruption on the positive side of it, the light will stay on. So let's see if it troubleshoot codes. Let's just do continuous checks here. If I clear the code, let's see if this light will go out. These codes. Yes. Okay, light went out when I cleared the codes. All right, now we're going to interrupt the downstream once let's go ahead and interrupt the downstream O2 sensors. Unplug it for a second, plug it back in. And does it stay on if I interrupt it a few times? So if you got intermittent wiring on your hot that's coming in, it will definitely keep the heater circuit on. Let's go to live data. Let's see if it says on for a heater circuit for downstream now. Says bank one, sensor one, bank on sensor two. No, it actually says it's off. And it says it's drawing 1 amp. Okay, now it's even brighter because I did 2 of these. So now I got a brighter light here. So if there's an intermittent on the positive feed that comes into the ECU, it's going to turn on the oxygen sensors. And let's turn it off. Let's be back here first. Turn it off. Turn it on. Make sure the light's off. Go back to the live data. Go back to the oxygen sensors. It's off on all those. No fault, no fault, no fault. Let's make a fault again. We'll see if it shows a fault when I do that. Yep. So it says fault on bank 2, sensor 2. Yep. Okay. That was an upstream, I'm sorry. So bank 2, sensor 1. So that faulted on the bank 2, sensor 1 upstream. And let's see if I can make it fault on the downstreams. Yep, it faulted. Had an intermittent connection time for the downstream, and it ended up faulting. So all these say yes fault now. Turn this off. Keep that on. Now it says no fault. So it gets its grounding through the ECU on the ECU pins. If I get an interruption on ground, does it actually do the same thing? So if I get one of these out of here, let me check. Okay, it doesn't deal with that one. Let's see the blue one here. Yep, to just kill the power to everything. So not so much on the ground side, it's the positive feed side of the oxygen sensor. If it has an intermittent positive feed going into it, it will air out. So I could hook up 4 wires, have 4 representing all 4 of the oxygen sensors, but this is enough test right here to tell me that the ECU is good. And it's right now it's showing no faults and stuff, but if you have an intermittent positive feed on it, it will error out. So like if I take this off of here and air out all of them, it'll say yes fault on all of them. So I don't know if you can't even see that right there, but I don't even know if you can see that at all. But it says yes fault. Let's reset the ECU. The light's off now. Now it says no fault. No faults at all, unless you interrupt the power feed line going to it. Not necessarily because I interrupted the grounds and that didn't do anything. So it's got to be on the positive feed side going to the oxygen sensor. It's just not the ground feed side. It's not the ground switching side. Because I can interrupt. This will do upstream and downstream fault. This one will do an individual fault. Let's see. It may do 3 or 2 of them at least. Let's see. Okay, yep. So the upstream, and that's what I'm hooked to, both upstreams just faulted. So as you can see, I just undid the upstream ones, and now it's just only saying that upstream is faulted. Now let me go over here and I'll just do the downstream ones by itself. Let's reset this again. And let's just do the downstream intermittent. That's all I had to do is barely get a disconnect on it, and now it's saying fault on both downstream sensors because they're paired grounds on the wire diagram. This is for Tony Cox. He gave me a phone call. He's local here in Monroe, and said that nobody really wanted to work on these. But on the wire diagrams, I marked it because on the ECU itself, they have a shared common ground on the O2 sensors. So that's why even if you just faulted one, it should fault both of them if the power feed fails coming in. So if it only shows one sensor, that would be kind of weird because it should fault both of them. But we can test that out, even though it's on a paired ground. How can we make a single sensor fault show up in the trouble codes? Let's go to trouble codes and see if it says anything. Let me read it again. And the light's still on. So it's not showing a code. Let's look at freeze frame. Nothing shows on that. Let's go to active test. Let's see if I have a active test for the O2 heater circuit. Output test mode. Let's see if it's under that. Yep, that works with it. They get it out of there. Exit out. Get back into the ECU. When I just went to the output test mode, it turned on the heater circuits and then turned them off. It's not grounding through this ECU, so nothing is absolutely wrong. Nothing at all is wrong with this ECU. Something, you got an intermittent wire issue. Something is definitely going on with the wiring. Because even if you barely had like a disconnect, like I'm just, there it was, just barely disconnecting that in a fault, it made the heater come on. But on the live data, if you go down to let me just see where the heated oxygen sensors are. So it said heater control, bank 1 fault. So that's what it is. Undid the upstream O2 sensor. And it looks like if there's a way else. I guess the only other way that you can do it is if you clear codes. But there has to be something intermittent with the wiring on the positive feed side. Because this circuit detects individual. But I'm going to hook it up to the other connections. Well, it really won't matter because they're paired grounds, so it doesn't really matter. But how does it tell that one of the sensors and not the other is messed up? Is it because of the switching voltage of the O2 sensor is not matching up to the other bank, like the downstream? Because he was saying it was a bank 2, sensor 2 that was giving him the issue. So if it triggers and stays on, that's because he unhooked the other side. If he unhooks the bank 1 sensor 1 with the key on and plugs it back in, it's going to stay on, just like this bulb. And you got to clear it every time. So every time that you clear it, it'll make the light go back out. So unless you got something wrong with the wiring, wiggle the wires, have a test light on it. That would be the only way to just erase codes here. See, the light goes out. So I'm going to let the ECU run here for a minute. It's already pretty warmed up, as you can tell on the thermal camera. Everything is pretty warm on the ECU itself. My 8 ohm resistors here, these are 50 watts a piece. They're not even getting warm because the light ain't even kicking on anymore. So let's get a little focus on that. Here we go. So I got good data. I got good powers and grounds. Even if I interrupted the grounds here, it's not really going to do much anything as far as the ECU goes because I got it only hooked up to 2 grounds on the ECU. and that's on pin 25, and I think it was 103. Yep, 103. That's the only two. I do not have it hooked up to 76 and 77 because it's common to pin 103. So I didn't even have to hook up the other ones. I'm not putting all the loads on the vehicle. I'm not worried about it. I did test it to make sure that I did have grounds on those other pins, and made sure everything was good there. So everything's good. I took this chip off at first thinking that it had an issue, and from what I checked with the chip when I was just kind of testing everything, and then I wanted to heat this up and take it off to check the chip individually, all the pins and stuff, make sure everything was good with it. It was not shorted at all. So I ended up soldering that chip back on, and I got to put some conformal coating back on it to kind of protect it from elements or anything. But none of these drivers here, all these drivers here control the actual O2 sensors. So if I fault the O2 sensors, let me fault all four of them. Just an intermittent fault. Go to my live data. I should have all four of them aired out. Yep. Says heater control, bank 1, bank 2. Both upper and lowers, all faulted. So let's see, do we see any temperature coming up on these 4 transistors yet? Let's see, let me block this one. Yeah, I can see it on this chip right here. And we're gonna see if it's kind of sucking through the paper now. But all right, so I haven't really seen those chips heat up. So it's probably because I got that light. That light is actually about right at 3 ohms. And then I got these. These are 8 ohms a piece. So that'd be 4 plus 3. So the total resistance there is not really high enough to really mess with anything or heat up this circuit, because I don't feel anything with that circuit that's heated up a lot. This one's actually pretty warm. It must be the power. I got this one here. That's a voltage regulator, and then this one right here. It looks like a power goes to this big, looks like 0.1 ohm resistor, and that looks like it. It looks like everything's okay with this ECU. I'm not seeing any issues whatsoever, other than if you have an intermittent power feed going to the oxygen sensors. But I'll let you listen in here. You can actually hear the. I don't know if you can hear that. You hear those data lines actually coming in. So I'm just going to leave it run for a little while, and we're going to see if it. I'll reset the trouble code real quick. See, it's not showing, but it's on right now. That's because you got an intermittent power feed issue. So I was trying to replicate the problem that the customer was having with the oxygen sensor being on. I'm surprised both of them are not on, or maybe you know, he didn't see that it was on the other bank, but Yeah, they're paired together in the ground, so both of them have to be on. I mean, I could hook up 4 lights, put up the breadboard and all that stuff, but it's not going to make no difference because they're grounded together inside the ECU. Let's erase these codes again. Okay, lights out. Okay. Let's do output mode test. On. So lights come on because the heater circuit's kicked on, and off. On. Off. Okay, not really seeing anything there. So I say have the key on, wiggle the harness around, see if if you're wiggling the harness around and you see your test light come on, that means you got a bad connection somewhere. Because I'm not seeing it on the grounds, even when I pulled one of them off at a time. One of them totally turned the computer off. The other one is just a ground for secondary parts of the circuits and stuff by the wire diagram. So I didn't want to have that one just floating. Because it may interfere with my test. It may interfere with the data signal for, the data bus coming in. So I want to make sure that everything that I test is I try to replicate the customer's issues that he has. So now I'll just let it run for a little while and we'll see if anything changes. We'll come back to it. If I see that light kick on, I'm just gonna let it run overnight and we'll come back here tomorrow morning and because right now it is 2:41 in the morning, so I need to go ahead and wrap it up for the night and see what it does for in the morning. I may go ahead and get out let's see if my other tool will actually read the VIN number on that. I can get IDS or something to see if it can read a 2003. But I talked to him over the phone, and I kind of explained to him. But the video will kind of show him a little bit better because if it was um, a problem on the positive feed lines, it will throw off the O2. So maybe we need to add a power feed line going to those O2 sensors because somewhere in the harness is screwed up. Maybe not the trans because you said that you replaced the transmission harness. They said it was a lower one by the transmission well. So, but he didn't replace the engine harness side. So the engine harness side, I'm thinking that it is part of what hooks up to the ECU and to the rest of the car, but I guess that's something that you'll have to check out. I'm not real familiar with the Ford harness bracket, the points where you can disconnect everything. I know you got the engine harness stuff that you can take off of the engine and keep it separate, but a lot of this stuff actually goes to transmission and all that too. So I want to just kind of put that out there for anybody else that might watch this video. Um, I'm thinking it might be in his harness. He might have some poor connection somewhere. There's a pin that's widened out, or just something is not making contact in there. And when you wiggle the wires, it makes the O2 heater circuit come on, and then eventually throws a code for it. And he's hunting down, thinking it's O2 because he said he replaced it like 4 or 5 times, and thinking that the O2 sensor is messing up for some reason, but I don't think it is. I think it's just a bad connection somewhere because even if I, you know, barely just get a disconnect for a second, it comes on. So I'll turn this off to reset it. Turn it on, it comes on for a second and goes off. So we'll just let that run now, and then we're going to see if anything happens with the ECU on. It should be completely fine to run. It's voltage. I got it set at 13.4, like as if the engine's running. I'll kind of turn it down a little bit too. I'll put it about 13 volts. Maybe I'll do like, yeah, I'll do 13 volts. Let's see what it is without the scan tool hooked to it. See if the voltage looks good. Yeah, it's only 0.26 of an amp. So 260 milliamps at 12.6 volts. So I'm just going to turn it about what a charging voltage would be. Maybe about 13.7. See if it stays consistent right about there. Okay. 13.8, 13.7. My power supply is not a real stable power supply, so I'm eventually going to upgrade that. Okay. We'll leave it about that, about 13.4. With the scan tool hooked up to it and everything, it's drawing about 0.64 amps at 13.3, 13.4 volts. So let's go ahead and call it a night, and maybe I'll just let that record. My oscilloscope's probably going to turn off on its own, so I'm just going to disconnect that and charge it because it's running on battery right now. Let it charge up and stuff. I could probably leave it. It should be fine.